Hi guys, Dr. Musk back again. Here we're going to focus on chapter 11.7, which is just a little sort of application of what we just learned about the polarity of molecules in 11.6. So to do this focus on medicine, we're going to look at vitamins, all right? So vitamins are organic compounds that we need in order to have normal cell function, and we can't make them ourselves. So our body can't make them, we have to consume them. All right. And there are two types of vitamins that our bodies consume: fat-soluble vitamins and water-soluble vitamins. All right. So those have very different types of chemical structures. And the difference between them is how polar they are. So we just did this discussion of polarity. All right. We know that polar organic compounds contain polar bonds, and also that the bond dipoles don't cancel out with one another. All right, let's just look at a couple of examples of vitamins and see what the difference is between the ones that dissolve better in fat, the ones that aren't as polar, and the water-soluble vitamins that are more polar. So here is an example, vitamin A, of a fat-soluble vitamin. And if we look at its structure, almost all of that structure is hydrocarbon. The only part of that entire large structure with any polar bonds at all is right there at the end. So on the whole, we would say that vitamin A is very nonpolar. So nonpolar molecules like vitamin A dissolve well in nonpolar fats. So we say that vitamin A is a fat-soluble vitamin. Here is an example of vitamin C. Look at all those oxygens and bonds between oxygen and hydrogen. So I see a total of 4 different alcohol functional groups, and then also this functional group that we see with the carbonyl and an oxygen on one side, we call that an ester functional group. So we've got an ester functional group and a number of hydroxyl functional groups, or you can call them alcohol functional groups. Now, because of that great number of very polar bonds, we say that vitamin C is a water-soluble vitamin, all right? It is very like water in the way that it does its intermolecular forces. It's very, very soluble in water. So vitamin A and other fat-soluble vitamins, they get processed and stored in the liver and other fats around our body. Whereas vitamin C and other water-soluble vitamins, they are delivered where they need to be delivered in aqueous solution, but we pee them out really quickly. All right? It's almost impossible for us to overdose on the water-soluble vitamins because if we have too high a concentration of them, they're just processed and excreted in our urine. But if we eat too much of vitamin A or other fat-soluble vitamins, they can actually become toxic because our body doesn't get rid of them as fast. We can't pee them out very quickly because they're much more fat-soluble than they are water-soluble. Thank you guys for paying